Hello students, welcome to Sri Siddheshwar Women's College of Engineering Solapur. We are dealing with the unit of partial differential equations and their applications. From this unit, we are discussing applications of partial differential equation. Out of the two applications of partial differential equation as per our syllabus of M3, we are discussing one-dimensional heat flow equations. The theory behind the solution of one-dimensional heat flow equations we have discussed in the last video lecture. Now we are going to solve some examples from this topic. Let us see first example. The example is find the temperature in the bar of length 2 units whose ends are kept at 0 temperature and internal surface insulated if the initial temperature is sin pi x by 2 plus 3 sin 5 pi x by 2. Here, carefully note that not a single partial differential equation is given. So you have to understand that this example is from the topic of one-dimensional heat flow equations. Here, bar length is given. So it indicates that it is from the application of one-dimensional heat flow equation. Here temperature, which is denoted by U, is a function of two independent variables. First is length of the bar, which is denoted by X, and the time, which is denoted by T. The length of the bar varies from 0 to 2 units. So at the first end of the bar, X equal to 0 and at the second end X equal to 2. At these two ends the temperature is 0. So U of 0T is equal to 0 and U of 2T is equal to 0. So these are the conditions, and one more condition is given, that is the initial temperature is sin pi x by 2 plus 3 sin 5 pi x by 2. So we can write this in mathematical form as U of x t equal to sin pi x by 2 plus 3 sin 5 pi x by 2 at t equal to 0. Let us see the solution. First write the one-dimensional heat flow equation in general form, which is given by dou u by dou t is equal to c square dou 2u by dou x square. Now we know its solution is given by u of xt is equal to c1 e raised to minus m square c square t into bracket c2 cos mx plus c3 sin mx. The theory behind this solution we have already seen in the previous video lecture. Now our aim is to find the values of these three constants c1, c2, c3 using the three conditions given in the example. Now let us write the conditions given in the example in mathematical form. The first condition, u of xt equal to 0 at x equal to 0. It is nothing but the condition that at the first end of the bar the temperature is 0. Second condition, u of xt equal to 0 at x equal to 2. That is at the other end of the bar the temperature is 0. And one more condition which is given for the initial temperature of as u of xt is equal to sin pi x by 2 plus 3 sin 5 pi x by 2 at t equal to 0. So we have to find the values of these three constants c1, c2 and c3 using these three conditions. So let us use the first condition, that is at x equal to 0 temperature is 0. So put x equal to 0 in this equation 2 and you can get value of one of the three constants. So from 2 and 3 we get this LHS at 0, no change in this multiplier, c2 cos 0 is c2 and c3 sin 0 becomes 0. So from this equation we can get c2 equal to 0. So with the first condition we have got the value of c2 at 0. Now use this value of c2 in equation 2 so that you will get more finished solution for the temperature function u. So equation 2 becomes u of xt is equal to c1 e raised to m square minus m square c square t into c3 sin mx. You may collect the constants together, which gives us c1 c3 e raised to minus m square c square t sin mx as function u. Now still we are having two conditions and we are having two constants. So let us use the second condition denoted by equation 4 in this equation 6. So we have to put x equal to 2 in equation 6. And obviously for x equal to 2 we are having u equal to 0. So with this we get this result, and from this we can write sin 2m equal to 0. But we know that sin n pi is always 0 for n integer. So this 0 can be replaced by sin n pi. Now taking inverse sine ratio on both the sides of this result, we get 2m equal to n pi. From this we get the value for m as n pi by 2. Now replace m in equation 6 by this n pi by 2 value. So equation 6 becomes u of xt is equal to c1 c3 e raised to minus n pi by 2 bracket square c square t sin n pi x by 2. Now with this m is equal to n pi by 2, we have introduced n integer in the solution. For different values of n, you will get this condition satisfied. So here we have got series of solutions. So let us write this in general form, where u of xt can be written as summation or n from 1 to infinity bn. c1 into c3 is constant again, so it can be written as some b, but for different values of n you will get these constants different. So here we are writing it as bn. So u of xt, that is temperature function, is nothing but the series of solutions. So we have to use third condition to find the actual value. Now third condition is for t equal to 0. For t equal to 0, u of xt is sin pi x by 2 plus 3 sin 5 pi x by 2. So let us use that third condition. For t equal to 0, this result 8 becomes like this. But already we are having the condition for t equal to 0 from equation number 5. So from 5 and 9 we write sin pi x by 2 plus 3 sin 5 pi x by 2 is equal to this series of solutions. Now if we expand this RHS, that is if we can write RHS with different values of n in addition form, then comparing both the sides we get, so here this series is written in the actual addition of the terms with different values of n. Now if we compare LHS and RHS, first term we can get b1 equal to 1, second term on LHS and fifth term on RHS we get b5 equal to 3, but these terms are absent, so it indicates that b2, b3, b4, b6, b7, b8 and so on up to infinity are 0. So comparing LHS and RHS terms, we get values of b as b1 equal to 1, b5 equal to 3 and the remaining constants equal to 0. Now using these values of b in equation 8, we can write the solution for temperature function as u of xt is equal to e raised to minus pi by 2 square c square t. Here n equal to 1 is put for the first term, so b1 equal to 1 we are using here. b2, b3, b4, b6 so on, these terms are 0. So we can write only for the one more term, that is b5. So b5, that is 3. So we get the second term as 3 e raised to minus, now here n will become 5. 5 pi by 2 square c square t sin n pi x by 2 will become 5 pi x by 2. So this is the required temperature of the given bar as stated in the example, using which is satisfying all the three conditions given in the example. You may verify this result by cross checking those condition results for different values of x as 0 and 2 and for value of t as 0. Now let us see one more similar example from this topic of one-dimensional heat flow equation. Example is, solve the equation dou u by dou t is equal to dou 2u by dou x square with the boundary conditions. U of x0 is equal to 3 sin n pi x, u of 0t is equal to 0, u of lt equal to 0, where 0 less than x less than l. So here from this partial differential equation, it is clear that u is function of x and t, x is lying between 0 and l, and three conditions are given to you to solve this equation. Equation is very similar to the first one, but only difference is that here c square is 1. Let us see the solution. So we have to write one-dimensional heat flow equation which is given in the example. So its solution will be obviously u of xt is equal to c1 e raised to minus m square c square t into bracket c2 cos mx plus c3 sin mx. But comparing this equation with the standard form, we get c square is equal to 1. So this solution becomes u of xt is equal to c1 e raised to minus m square t, c2 cos mx plus c3 sin mx. Now let us write these three conditions given in the example one by one. So u of xt is equal to 0 at x equal to 0. This is nothing but u of 0t is equal to 0. We can write this condition like this in u of xt form. Second condition is u of lt equal to 0. We can write this as u of xt is equal to 0 at x equal to l. And third condition is for t equal to 0, u of xt is equal to 3 sin n pi x, where t equal to 0. So with these three conditions, we have to find a particular result, particular solution for this given partial differential equation. So let us use the condition 1 which is given in equation 3. So we have to put x equal to 0 in equation 2. With this substitution of x equal to 0 in equation 2, we get LHS 0 as per condition 3. So 0 equal to c1 e raised to minus m square t c2. From this we get c2 as 0. So equation 2 becomes u of xt is equal to c1 e raised to minus m square t into c3 sin mx, that is c1 into c3 e raised to minus m square t sin mx. Now we have to use the second condition to get the more particular solution. So with second condition, that is u of lt is equal to 0, that for this we have to put x equal to l in equation 6. So from this we get this result and we get sin ml equal to 0. Again we have to use the trigonometric result, that is sin n pi is 0 for an integer. So with this result we can write sin ml is equal to sin n pi. Taking inverse sine ratio on both the sides, we get ml is equal to n pi, and from this we can write m is equal to n pi by l. So you have to replace m with this result in equation number 6. With this you have introduced the integer n. So for different values of n you will get different solutions. So we get a series of solutions which is written as u of xt is equal to summation or n from 1 to infinity bn, where bn is nothing but c1 c3. So bn into e raised to minus n pi by l bracket square t into sine n pi x by l. Still we have to use one more condition to get the more particular solution for the given partial differential equation. So let us use the third condition, which is given by t equal to 0. So with t equal to 0, equation 8 becomes u of xt is equal to summation or n from 1 to infinity bn sine n pi x by l. Now from the condition we are having u of xt at t equal to 0 as 3 sine n pi x. So comparing LHS and RHS, we get bn is equal to 3 and l equal to 1. So now use these two values in equation number 8 to get the solution. So we get u of xt is equal to 3 into summation or n from 1 to infinity e raised to minus n square pi square t into sine n pi x. So this is the required temperature of the given bar as stated in the example. You may verify this answer by substituting the values of x as 0, x equal to L and t equal to 0, and you will get the same result as given in the example in terms of different conditions. So with these two solutions, referring these two solutions, you can solve the different examples from this topic. Thank you for listening patiently. Have a nice time.